basics of database management system. We have many concepts we need to cover. Now, so our module 2, we need to learn fundamental part, concept things. Yeah. So our part A, more on databases and DBMSs. 8.1 are the advanced features of DBMS. Yeah. First, I want to talk about 3 of the advanced features in DBMS. Yeah. Because we want to see how much we can do in a typical DBMS. Yeah. All right. The first feature I want to talk about, transactions in DBMS. This concept, transaction concept in DBMS. Yeah. But here, I want to point it out, this transaction concept in our DBMS context is quite different from our everyday life transaction. We have our natural language understanding of transaction, right? Yeah. So when you go to a bank, you do a lot of transactions, you know, that kind of thing. But in this context, DBMS context, it has its special meaning. Yeah. Here, I like to explain this transaction context, concept in DBMS concept. Yeah. All right. Definition of transaction. Yeah. Later, when you see this term in this class, you need to look at the context. Yeah. Is it the regular transaction meaning or our DBMS transaction meaning? Yeah. You need to try to tell, well, which one we are using. Yeah. All right. Yeah. Definition first. Define a business task. Yeah. We want to define a business task in what way? Contain. Oh, sorry. Oh, yeah. Thank you. Yeah, I need to get this one. Okay, I'll lock it. That's not all right. I need, yeah, thank you. Yeah, yeah. Just remind me. Yeah, I didn't check. Yeah. Oh, yeah, good. Okay. All right. This definition, yeah, containing a sequence of database accesses. This access is just queries. Okay? Yeah. We use queries to access database, just queries. All right, yeah. Queries. Okay, yeah. Yeah, I don't know if my spelling is, is correct. Looks weird, yeah. Yeah, let me write this way. All right, okay, yeah. A sequence of database that cannot be separated. That's the important thing. All right, yeah, that's the definition. But let me explain the importance. Why we need to define this concept in DBMS, because it is so important. Now, here, let me use a simple example we have in our real world experience. Now, think about, we may need to do a sequence of banking transactions. This banking, yeah, here, banking transaction, that's our regular transactions, all right? Not the DBMS transactions, yeah. When we do a sequence of closely related banking transactions, think about this situation. Now, we withdraw certain amount of money from account A, okay? After we withdraw that amount of money, we make deposit to another account, account B. Yeah, same amount of money. Yeah, this kind of simple transaction sequence. All right. Yeah, but here, in order to make the whole sequence work in the right way, we want to make sure the amount of money that we withdraw from bank account A is the same as the amount of money we deposit in account B. All right, yeah. Otherwise, we will get some problem. So we worry about that. All right, but think about these two transactions. If it is separated by some accident, think about that. The system crashed. Before you make a deposit in account B, the whole system crashed. Think about that. All right. Yeah. Here, the ideal case, we want no separation between these two transactions. But due to some technology problem, earthquake, so many different things that could happen, right? Look, then you cannot complete some of the accesses or transactions, regular transactions, right? Or queries, some of the queries for the whole task, right? Here you define the whole task. Yeah, this whole thing, this whole sequence, that's a complete task. That is a complete task. You don't want to break it in the middle. Now, you want to make it work as a whole, right? As a whole. Then, if something happens in the middle, stop it. Yeah, because nobody can control some natural disaster, and electricity, all those things, tornado, right? Yeah, nobody can guarantee you can always complete your whole sequence of tasks. Now, then you need to protect your data. You need to protect your business data. Yeah. So here you can see this transaction concept in DBMS is designed to solve that problem. All right. Now you know the importance, right? So important. Yeah. All right. So then the question is how, right? Yeah. We know. Yeah. We agree. It's important. But the question is, how can we implement that DBMS transaction? Yeah. This time, DBMS transaction. Now, here, let me describe the basic steps. Implement DBMS transaction. Yeah. All right. First, the first step, define a starting point of a transaction. You have a sequence of queries. Yeah. Suppose you have a sequence. Yeah, when we have a sequence of queries. Yeah. But we do not know starting from which one there's the starting point of our DBMS transaction. So you need to tell DBMS here. Yeah, because here you need to tell DBMS the starting point. Okay, in some way, right? In some way. Okay, yeah. Yeah. Later we can see, yeah, in what way? Yeah, just some special way. You tell DBMS starting from this query. That is the definition of our new transaction. Yeah, the first step. Second step, after the starting point, then you provide a sequence of queries for a task, your business task. Yeah. It covers certain number of queries. All right, yeah. Yeah. Then at the end, commit the transaction, right? At the end point, you want to execute the whole sequence as a whole. So you send the command, commit. You send the commit command to DBMS. Tell DBMS, to commit this transaction. Then the DBMS needs to execute the whole sequence from beginning to end without interruption. All right? You cannot break it in the middle. Yeah. But you may ask this question, because when something happens, the DBMS cannot prevent, right? Those disasters, electricity problem. Yeah. How to make DBMS stop the damage caused by any accident? Stop the damage. Yeah. The last step. Roll back if there is an error. All right. During the execution, okay? During the execution, if anywhere in the middle there is some accident, then DBMS will roll back to the beginning point. All right? Roll back to the beginning point. Don't do anything. All right? Yeah. Don't do anything. Yeah. Yeah. How can that happen, right? It looks not easy. Yeah, you think about it. It looks not easy. Yeah. How can you roll back? Okay. Yeah. Yeah. Here at this point, we may not have that part of the knowledge to understand that. Yeah. After we learn a little more, we need to learn inside DBMS. We need to compile the query statements, make it executable. Yeah. After we learn the compilation concept inside DBMS, then we can understand better. Yeah. Inside DBMS, all the queries, we need to compile them one by one, make those queries executable machine code, okay, executable code. Then DBMS execute those executable instructions inside DBMS. Yeah. Similar to our programming languages. Okay, yeah. So after we study that part, then we can understand this transaction better. But here, if you just use these 4 steps to understand a typical transaction, a typical DBMS transaction, that's enough. Yeah. So that's all we need to do. Yeah. To make sure the whole transaction sequence works as expected, as designed. Yeah. All right. Yeah. Then properties. Here, let me talk about the properties of a transaction. 2 properties here. The first property, isolation property. Yeah. All the queries, or sometimes we also call operations, database operations, queries. Yeah, we refer to the same thing. Yeah. All the queries, operations must be isolated. Okay, yeah. So make sure isolate. No interference from other transactions. Yeah, yeah, sorry here. Yeah, isolation means let's say 2 different transactions. They work in isolation. Yeah. Yeah. Transaction 1, transaction 2. All right. Yeah. They work in isolation and there is no interference between them. Yeah. So that's the isolation property. Yeah. Second, atomicity property. Atomicity property. Atom. Now, we know atom, the meaning atom, little small particle, atom, right? Atomicity, yeah. That means the whole thing should work as a whole or none or whole. Yeah, that's the meaning, atomicity meaning. All or none database operations are executed. You cannot execute some of them, part of it. You have to execute the whole sequence or non-zero, right? Yeah. Only in that way, you can do your business task in the right way. Okay, yeah. Because now, later, when you get the system back to the normal working condition, you can continue, you can run that transaction another time, right? But you don't want to damage your data, right? You don't want to do it in the wrong way to corrupt your data. And that's disaster. Yeah. So we would rather, if something is wrong, we would rather put a zero there. Okay? Do nothing. Do nothing is better than do part of it. Yeah. That's the essence of this concept. Okay? Yeah. All right. Yeah, that is our first advanced feature of DBMS. Yeah, I want to talk about. Yeah. All right. And this feature, quite important. Yeah. Later, I may like to give you some concrete examples. So let you see it. Let you play around. Yeah. So in my examples, I plan to use 2 languages. Yeah. Even simple examples make you feel good. Yeah, because you have that experience. Later in your programming, you may have the situation you need to use transaction. Actually, it's quite common to use transactions. So I will give you in 2 languages, Java and PHP. 2 examples. Yeah. In Java, yeah. So we actually, in Java, it is very popular to do database transactions. Yeah. And the recent database handling way, actually people put all queries in transactions. Even one single query, people also put in transaction. Yes, that's why it is so common in Java. All right, yeah, PHP, yeah, not that common in Java. For example, in Java, there is a database framework called a Hibernate framework. Yeah, here, Hibernate framework. In Hibernate, all database queries are placed inside transactions. Yeah, even one query, yeah, put inside one in transaction. Begin and in the middle, only one transaction. Yeah. Yeah. Why? But there is a reason. Yeah. Because here you use one query. How about later you may add more than one queries, right? In your business task, at the beginning, you use one query. Think about after some time, you modify your business task, you may add a few more queries. Then it's better to place them in one transaction. Okay, yeah. All right, so that's the transaction concept. Next, yeah, here, yeah, I did, yeah. All right, yeah, we will go there. Concurrency control. Let me talk about the concurrency control concept. Yeah. All right, this feature, yeah. What's that? Yeah, here in DBMS, we need to do things like this. Support, we want our DBMS support several users trying to update the same data, do so in a controlled manner. Yeah, what's that? Think about. Yeah. In a typical way, using a DBMS, multiple users may access the DBMS at the same time, and especially multiple users, they want to modify the same record in the table. How about that? Same record, same person, same record. One person wants to change this piece, then another piece, you know, Then if you do not do this concurrency control well, data messed up. Okay, data messed up. Yeah. So your DBMS needs to design some mechanism, an advanced mechanism to protect the data. All right. Make those users work on the same piece of data in a certain order. Okay, one person, the first user, you must complete your modification first. Then the second one in the line, then your turn, you complete it completely. All right. Yeah. So then for each user, you have your chance to complete your query. Yeah, it's pretty complicated. Yeah. The whole implementation is pretty complicated, but the DBMS has to have this feature. Otherwise, the DBMS is not very useful. Yeah. All right. A good DBMS must include this feature. A good. Yeah. Here I put this good. Yeah. In our textbook, it says a DBMS must include this feature. Yeah, because the reason is in DBMS history, Microsoft Access, yeah. Microsoft Access, this DBMS, it didn't have this feature for quite some time. Yeah. Yeah. Only in recent 10-something years, then it added this feature. All right. Before that, it can only provide service to one single user, not concurrent users. All right. Concurrent users, you have to, wait your turn. So one use access. After that, another one use, yeah. Then it is very slow. Yeah. Yeah. But if a DBM has this concurrency control, then those users, they can work at the same time, but DBMS will arrange in an efficient way. So you won't feel very slow. Those users, you just feel you get your service immediately, yeah, without any delay. Yeah. But the DBMS will provide services to all the users, concurrent users, without any delay. All right. You just think about that, this feature. Those are the advanced feature, yeah. But Microsoft Access, old time, yeah, not in that way, yeah. It is very, especially there are multiple users. If you want to use Microsoft Access powered web applications, the performance is very slow. Yeah, yeah. I saw some examples before. Yeah, yeah. One of my students developed one web application for a professor. Okay, yeah, yeah. Not many users, but whenever there are more than one users, the system is very slow. Okay, yeah. The reason is, yeah, at that time, yes, very old time, yeah, 10-something years ago, yeah, Microsoft Access does not support concurrent user, but recent years, yeah, although recent years, yeah, close to 10 years at least, close to 10 years, okay, yeah, and Microsoft Access can support 255 concurrent users. That's quite some number, yeah, because many mid-sized companies, if they can support 255 concurrent users, that's pretty enough. All right? Yeah, mid-sized companies, they're not too big, okay? Not the Amazon, okay? Not the giant. Yeah, yeah. Because my wife, she's working in modern Chinese school. Yeah, that organization, Modern Chinese School, that organization, they have 400 something members, 400 members. But you cannot imagine 400 members access their system concurrently, right? It's rare. Yeah, it's rare even 200 members access their system concurrently, right? Yeah, so it's quite enough. Yeah, 255. So they use the system, quite well in recent years. Yeah, old time not good. Yeah, old time whenever people need to do registration, that time, yeah, start registration, well, then crash. Nobody can access the system. Yeah, crashed quickly. No, that's the old time story. Recently, yeah. So here, 255. Yeah. So that kind of support quite enough, yeah, for a relatively small organization. Yeah. But here you just need to get this concept in when you need to write your web applications. You should use a DBMS that can support large number of concurrent users. Not this, yeah, but this 250 are still very limited, right? Yeah. So if we use MySQL, then you don't worry about that. Our MySQL, I do not know that number. That number is quite big. Okay, thousands of. Don't worry. Yeah, thousands of concurrent users. Don't worry, it can support quite well. Yeah, all those users, they can feel response immediately. Immediate response. That's the power of MySQL. Okay, that's the reason. Yeah, it's a high quality production DBMS system. Yeah. All right. Yeah, a web application require this. Yeah, web application concurrent support. Extremely important. Yeah, especially think about Black Friday, right? Yeah, so important. Yeah, yeah. And in order to support Black Friday level concurrent users, you need a huge system, many servers, large number of servers. Otherwise, you cannot provide immediate response service. Yeah. All right. The transaction feature requires this one. If your DBMS does not support concurrency control, transaction feature cannot be implemented. Yeah. The internal implementation of transaction relies on this concurrency control feature. Yeah. All right. Yeah. All right. Yeah. So here, yeah. Think of, yeah. Yeah, micro DBMS for web applications. Yes. Try to avoid. So our conclusions, try to avoid. Yeah, because your organization sooner or later will grow, right? Yeah. Yeah. Quickly will grow, hundreds of thousands of concurrent users. How can you handle? Think about if in the middle you want to switch the system, then it's too costly. Think about if you want to change your DBMS from Microsoft Access to MySQL, how much work you need to do? Large amount of work. Yeah. So at the beginning, you should select a solid DBMS like MySQL, not Microsoft Access. Okay. Yeah. For your web application. For personal business, yeah, no problem. Yeah, only a very small store, just a few people use that. That's perfect. Yeah. Microsoft Access, so popular in that kind of small store type companies. Yeah, yeah. So popular. Yeah. All right. The third advanced feature I want to talk about, stored procedure. Stored procedure. Store, where to store? Store in DBMS. Yeah, it's called stored, but stored inside DBMS. Yeah, so let's look at the definition of that. Yeah, in form of functions. Yeah, procedures and functions, we know the same thing, right? So in form of functions with input and output. Yeah, so that is, we can write functions, we can define functions inside DBMS. Yeah. At this point, we know we can do queries, yeah, but you can define a function. In your function, you can put a logic. In function, you know, the control logic. Then you can put your queries. So you can write pretty complicated data manipulation statements in your function. Yeah, think about that. Yeah, yeah. So that's like, but we use SQL to write the function definition, SQL statements to write a function definition. Okay, all in SQL language, all in SQL. Okay, yeah. Execute a sequence of SQL statements in DBMs. Yeah, inside this function, you need to execute a sequence of SQL statements. Yeah, yeah, in some very special way, or in some relatively complicated way. If in simple way, you do not need to write a function. Think about that, right? If we just execute certain number of queries in sequence, not very complicated, we can just write our regular queries, right? Yeah, but sometimes you need to do relatively complex manipulations among some of the queries. Then you put that in a function. You write it in a function, all right? Yeah, in that way, you can do much more complicated data manipulation. Yeah, all right. Yeah, so there, what's inside a typical function? Yeah, part of database definition. Yeah, so you can put some database definition in your SQL statements. Yeah. Here, the database definition we also call the metadata. Metadata, descriptive data. What's the metadata? Descriptive data. Yeah. In next slide, I will also explain this concept. Yeah, another time, metadata. Yeah, all right. Can be called a stored procedure. Yeah, sometimes people also call just procedure. Okay, stored procedure. Yeah, or simply procedure. Yeah, can be called locally and remotely from the application programs. Locally, that means you run the procedure on the same machine with the DBMS server, right? DBMS has a database server. Now you just run that procedure locally on the same machine, same DBMS machine. Yeah. But another case, remote case, yeah, on different machine. Yeah, that is quite usual, you know, quite common. Yeah, database DBMS is running on one server, but we need to make our web server. Yeah, here, DBMS running on one server. Yeah, DB. Yeah, let me just write DB server. DB server on one machine. All right, yeah, and the web server on another machine. Yeah, then you need a lot of communications between these two servers, right? Yeah. Yeah. One way you can do in M2, you can execute procedure. You can call a procedure. All right, you can run procedure remotely. All right, yeah. So think about that, right? Yeah. So it can be called locally and remotely from application programs. Yeah. In your web server, you use application programs. Yeah. So you can do a lot of things on stored procedures. Yeah. So we will see that. Yeah. Can be created in an application program. Inside an application program, we can write our SQL statement to create here, define a procedure, right? Create here, we can also say we define a stored procedure. We define a stored procedure by SQL code. Yeah, how do we define, right? Yeah, we use SQL code. SQL statements, a sequence of SQL statements. So we can define a stored procedure in our application programs. Yeah. All right. Can reduce data traffic on internet. Yeah. So here, think about that. Yeah. After we create a, yeah. So here the situation is after we create a stored procedure in the DBMS. All right. Yeah. Suppose we create it, we define it, we make it. Yeah. It is there. It stays inside DBMS. Yeah. Then we call it. After we create it, then we call it from an application program. Okay. We call this procedure from an application program, and this procedure is running in DBMS. In that situation, we can reduce data traffic. Yeah, because the procedure, yeah, let me call this procedure running completely in DBMS. And it only returns the result to the web server. Only result to the web server. Yeah. Intermediate data, it does not need to return intermediate data. Yeah. Because during the execution of the procedure, you need to generate a lot of intermediate data, right? Yeah. But all the intermediate data stays inside DBMS. You only need to send a final result back to the web server. So you can reduce the web traffic. You can reduce the web traffic. Yeah, yeah. Comparing a let's compare non-procedure way. Non-procedure way. Here I'm talking about procedure way to reduce web traffic. Now let's look at non-procedure way, the traffic. Non-procedure way, think about, suppose we need to execute a sequence of query. Query 1, query 2, a sequence of query, all right? Now, query N for the whole business task here, all right? But if you do not use the procedure, you use the non-procedure way, then each query you need to send to DBMS, right? One after another. Each query you need to send to DBMS. And the DBMS needs to send you back intermediate data, right? Each query, DBMS return your data result. Yeah, all the intermediate data will be returned by DBMS. A lot of traffic, right? Between DBMS server and the web server. At the end, you get a final result, all right? Yeah. Compare the procedure way. All the intermediate data stays inside the DBMS server. Yeah. So you can save a lot of web traffic. Think about that. All right. Especially a larger amount of data. Sometimes your queries may need to process large amount of data. How about that? Redundant intermediate data. So you can see the big advantage of this procedure way. Yeah. All right. So that's the another here. Then overall improve the performance. Yeah. So use the procedure way, especially for the complex data processing involving complex queries. Yeah. So you can improve the overall performance. Yeah. All right. Can enforce business rule. Another way to use procedure, enforce business rules. Yeah. Although you can use application program to enforce business rules, but this way more convenient. Think about it. Enforce business rules using procedures more convenient, because if you have that kind of implementation, then many other application programs can call the same procedure to enforce the same set of rules. How about that? Yeah. You do not need to rewrite implementation in different application programs. You don't need to rewrite. You already have in the procedure side implementation. Yeah. Yeah. All right. Yeah. Okay. Yeah. So after I introduce these three concepts, yeah, three concepts: transaction, concurrency control, and a stored procedure. Yeah. I like you to feel about it, to get experience on it, on these features. But I want to give you some code examples, let you play around so you can see how things work for these features. Yeah. But we cannot, yeah, because the concurrency control, that is hidden, right? That is hidden. We only enjoy it, right? Yeah, we cannot see how it works. Yeah. Yeah. So my examples only cover transaction feature and stored procedure feature. Yeah. So I plan to give you these four examples. Two examples for transaction. One for Java, one for PHP. Two examples for stored procedures. One for Java, one for PHP. Yeah. So let you just see the concrete code example. Yeah. So it will help you understand the concept better, and probably later when you work in the business world, you may have a chance to use stored procedures. Yeah. Transaction. Yeah. 80% of the time you will have the chance to use transactions. Yeah. Because more and more database queries will be placed in transactions for better protection, for better data protection. Okay. Yeah. But for stored procedure, yeah, the percentage will be a little lower. Yeah. But especially when you have some complex data manipulation activities, then it is very likely you may need to use stored procedures to do that. Yeah. All right. So that's the, advanced features part. Yeah. All right. Then part two, I like to explain a few more basic database concepts. Now, so we need to build up our fundamental understanding part. Yeah. All right. Define a database. Yeah. We saw in the example, I haven't shown you the demo. Yeah. All right. So here, let me just update. I post a software installation tutorial. Yeah. So this weekend, if you have a chance, for those who have not installed XAMPP software bundle for web development, yeah, you can use my tutorials to, I put a binary executable file, yeah, for the right versions, Windows version, Mac version, right versions, so you can download and install. But for Mac students, as I mentioned earlier, there is a potential problem. That is, the version I post, that's an XAMPP version. Yeah, that is, the regular XAMPP version. Yeah, and based on my experience, about 50% of the students using Mac machines have no problem. So you will get things work normally. Yeah, you're fine. But still, quite some number of students, they couldn't get it to work due to some reasons. Yeah, things, not connected, cannot start a server, that kind of errors. Yeah, so I hope you're lucky. Yeah, I hope our students lucky. But here, just let you know, if you get into that situation, do not be panic. Do not be panic. There is a solution. You can fix it. So you need to uninstall your XAMPP version and try to find a MAMP version, M-A-M-P-P. Yeah, yeah. Probably I should provide a MAMP version. Yeah, for my future student. Yeah, MAMP version. Yeah, approximately about 50% students. MAMP version. Yeah, so that's for Mac. Yeah, the first exam also for Mac, but internally there is some difference. Yeah, so that you can use the MAMP version to do everything we need from XAMPP. Yeah, but the MAMP version, yeah, the host name would be different. Would be different. You can find the host, it will use IP address as the host. You will find a special IP address in MAMP version. You use that to access your servers. Yeah, so that's, yeah. And XAMPP, you just use our usual localhost. Localhost, yeah. But for MAMP, it's not a localhost, some special IP address to replace localhost. Yeah. All right. Yeah. 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 Probably. Yeah. I may need to do a little more. Yeah. Yeah. Let me know. So if you have a problem, yeah, let me know. Yeah. All right. Yeah. Define a database. Yeah. Because if you get a software installation, smoothly, yeah, then from our next class, then I can do some demos. Yeah. So I can assume you have your environment set up ready, so I can run some examples. Yeah. All right. How to specify a database? First, structure. You need to specify the structure of your database. Yeah. And the structure, define tables, right? Yeah. So what kind of, you may ask, in what way to specify structure? Yeah. Typically, define tables. Yeah. All right. Yeah. Data types. Yeah. For each field in a table, you need to specify data types. Yeah. Constraints of data. Then among different tables, sometimes inside tables, there are many different constraints. Inside tables, between tables, yeah. So many different constraints you need to create, define, yeah. Then metadata. So now the metadata part, yeah. Descriptive data for data, yeah. Descriptive data for data. Here, the data here and the data there, different, yeah. The second data term, it refers to the business data. Business data. Yeah. So that's the data we need to work for our business. But the first descriptive data, yeah. So that's the, with the supporting data, right? Yeah. The supporting data. Yeah. We need to provide some extra information to help DBMS to arrange the business data in a better way. So the supporting data, yeah. So the descriptive data, yeah. That's the metadata part, yeah. Yeah. Metadata, yeah. So then, when we talk about metadata, it refers to database definition. Now, one thing, database definition, that's the metadata part, okay? Database definition. Table definition, that's the metadata part, all right? Table definition, yeah. Stored by DBMS in the form of a database catalog or dictionary, yeah. This concept, I will use one slide to explain catalog or dictionary. Now, from the name, you can guess, yeah, the concept. So what is that? Yeah, catalog, dictionary help us organize our business data. Catalog, okay, yeah, and yeah. So that is the basic definition of a database. Yeah. Next, database system. Yeah. We always talk about database. So what's the exact meaning of it? Database system. Yeah. Database and a DBMS software together. Yes. The database. Yeah. Our business data. All right. Yeah. The well-organized, structured business data, that database, okay? Yeah, that's part of the system. Then DBMS software, also another important part of the system. These two components together, yeah, we call it database system. Yeah. All right. This diagram, you can see, yeah, the database system. Yeah. We are here, we are programmers. Yeah. We could be both users and the programs. Users, yeah, we just use the database. Users, usually we refer to those people, they use databases, but they do not need to write code. Okay. They just use the features related to the database, DBMS. Yeah. But for programmers, we are not just the regular users. We need to write a code. In our application programs, we need to communicate with DBMS, with the system, with the database system. Yeah. All right. So then the DBMS software, this part, so you can see software to process queries, programs, yeah. Queries/programs, yeah. Here programs, you can understand procedures, right? Procedures are programs. You can understand that, yeah. but not application programs. Application programs are not controlled by DBMS. Okay, your application programs only communicate with DBMS. DBMS cannot control application programs. Yeah. So here, the programs here, we do not refer to application programs. Yeah. We refer to, procedures, DBMS procedures. Yeah. Those are programs. Okay. Yeah. Yeah. Software to access stored data. Yes. So then the data part, then two parts. Yeah. Stored database definition, metadata. Yeah. So the SQL statements we use for the database definition. Yes, only the definition part. Yeah. And later people also refer to use the schema. Schema of the database. Yeah. The schema is only the definition part, database definition part. The schema does not include the data part. Yeah. The business part is separated from the schema. Okay. Then this is the business data. Yeah. Here, that's the business data. All right. Yeah. Okay. Yeah. So that's the diagram of a typical database system. Yeah. Okay. Yeah. So with this diagram, so in your mind, you have a clear picture. Yeah. So when you work on a DBMS and the database at the same time, so you can get a good understanding. Yeah. So you will understand, how to manipulate data in different ways. Yeah. All right. Yeah. Okay. All right. It's pretty close to the end of this lecture. Although I have my last slide, I want to talk about application programs of databases. Yeah, actually, it's pretty simple. Regarding application programs in this class, I use Java programs and PHP programs. Yeah. For our web development, we use PHP programs, but sometimes I may need to use Java examples. Let you see how things work differently. Yeah, all right. Access database by sending queries to the DBMS. Yeah, and in my examples, I want to show you how to send queries to DBMS. In which way? Yeah, to send. Yeah, PHP and Java, they use two different ways, completely different ways. Yeah. So that's why I want you to see different communication ways. The mechanism are different, quite different. Yeah. All right. Create a database, yeah, because when we send database queries, we typically send SQL statements. We just send SQL statements. Our SQL statements, we can do the things I list here: create a database, create a table, all right? Create a stored procedure. That's SQL statement, yeah. Call a stored procedure, all right? Yeah. Do other regular queries, yeah. All these things we can do in application programs. How about that? So you can see almost everything we can do in application programs. Everything we can do in the DBMS, we can also do in application programs. Think about that. Yeah, how powerful it is. All right. Yeah. All right. Yeah. So, but in real world situation, things could be complicated. Although in your application program, you have the capability to do all those things, but it may not be a good way to do. Think about create a database. It's a huge business decision, right? It is a huge business decision. Although from the language perspective, we have the capability to do that in our Java program or PHP program, but we may not have the permission to do that. Think about that. We may not have the privilege to do that, right? Yeah, because you may mess up. You may mess things up, right? All right, yeah. Okay. All right, so let me stop right here. So I finished part A, all the slides I want to cover, so I completed, yeah, right here, yeah. Next time, part B, I will show you some query statements in PHP MyAdmin. I assume you're pretty much close to complete your installation. Now, yeah, at least most of you complete the installation. Yeah. All right. Yeah. That's it.